Hello everyone, myself Sai Prasad, a lecturer in Ahmedabad High School and the Junior College. Welcome to a series of the lectures of Intermediate Second Year Maths B. We started a discussion with the chapter Definite Integrals. What did we learn? We learned how do we use integration, after that substituting the upper limit and lower limit. Yes, we also learned few properties of definite integrals and we did most of the problems with that. Fine. Not only that, we have few more applications of definite integrals. Among them, the first application we are going to learn is finding the limit of an infinite series, right? We have seen this kind of infinite series in different chapters, right? Fine. If there is some kind of infinite series like this, so how do we solve it? How do we solve this kind of question into a single sum, and how do we find direct limit of an infinite series? That is what we are going to use the definite integral method. Okay, integration is nothing but summing of everything, right? Now we have to find the sum of this and directly integrating it in order to find the solution. Clear? Fine. Just see here, the question is given as under root n plus 1, under root n plus 2 and so on up to under root n plus n by n root n. The denominator is fixed, we need not change it. But what about the numerator? What is the general term for it? The general term for it is n plus r, under root n plus r. Yes? Yes or no? So, can I write this as limit n tends to infinity summation of I is equal to 1 to n under root n plus r by n root n, right? Let me write r is equal to 1 to n. Yes or no? Clear? What is it? Summation r is equal to 1 to n under root n plus 1, n plus 2, n plus 3 and so on up to n plus n. Is it clear? Any difficulty in this? No, right? So, now we are going to substitute only r is equal to 1. So, can I take this n root n as constant? So, or else let me put it there itself, limit n tends to infinity summation r is equal to 1 to n. Can I take n root n common here? So, I will get it as r by n inside, right? Yes or no? So, I can cancel this 1 by root n. I will be left with limit n tends to infinity 1 by n summation r is equal to 1 to n under root 1 plus r by n. So, this is the standard form which we are going to use. Clear? Did you understand? Now we are going to integrate only this particular function from 1 to infinity. Okay. Now we are going to integrate this to a larger limit, and what is the limit? Let us see. Now we have to integrate 0 to till where? Just check, here it is r is equal to 1 to n. So, what is the coefficient of n? 1. So, let us take it as 1 under root 1 plus the parameter r by n is always taken as x. Just remember that for all of the problems like this. So, what is the integration of 1 plus x? Root x ka integration is x power 3 by 2 by 3 by 2 from 0 to 1. So, let us directly substitute it. 2 by 3 into 1 plus 1, that is 2 power 3 by 2 minus, if I substitute 0, I will get it as 1. This is the answer. If you want to simplify, you can, or else it is fine. Clear? Did you understand? This is how we are going to solve a limit to sum by using this integration method. Clear? The only thing you have to remember is, after getting into this kind of function, you have to take r by n, r by n as x, and this is our integral function. Clear? So, from this the generalized function I will tell you, this should be in the form of limit 1 by n summation f of x, or simply f of r by n. Okay? That is nothing but this can be written as integral f of x dx for a particular limit. That is a generalized form, that is not a fixed, but we can use in that form. Clear? So, now let us do this problem. 1 by n plus 1, 1 by n plus 2 and so on up to 6n. So what is the form? So this can be written as lemon n tends to infinity. This is summation 1 by n plus r, where r is equal to 1 to, here this can be written as n plus phi n, isn't it? That is given as 6n, right? 6n can be written as n plus phi n. So 1, 2, 3 and so on up to 5n. Now n plus r. Now in order to get r by n form, I have to take 1 by n as constant. So I will get it as r is equal to 1 to phi n 1 by 1 plus r by n. Is it? So directly we can take the function as 1 by 1 plus x. Now the direct answer is 0 to, here the coefficient is phi, 1 by 1 plus x dx. What is 1 by x ka form? Log of 1 plus x from 0 to phi, that is we will get it as log of 1 plus, instead of x I will substitute phi, minus log 1 plus 0. This is log 6 minus log 1. Log 1 is however 0, I will get it as log 6. Is it clear? Did you understand? Shall we move on to the next problem? See here, the reduction formula, we know that integral sine power nx we did in the last sessions. Now we are going to write the direct formulas, that is integral 0 to pi by 2 sine power nx dx. So the formula will be n minus 1 by n into in minus 2, right? What is in minus 2? Again we have to go back to this. Again instead of n we are going to substitute n minus 2, everything we are, again it goes minus 4, minus 6 like that, and it should have an end point. That end point is nothing but half and pi by 2. If you do for more times you will directly get that, but we are going to generalize in such a way that if n is even, the formula is half and pi by 2. If n is odd, the formula is up to 2 by 3. Clear? Fine. Similarly cos power n also will have the same formula, no difference. When it comes to sin power nx, cos power nx, the formula is n minus 1 by m plus n, m minus 3 by m plus n minus 2 and so on up to 1 by m plus 1, where m is a odd number. Then when m is even, this is the formula. Clear? By using these formulas, let us solve few problems here itself. The first thing is sin power 7x dx from 0 to pi by 2. N is even or odd? It is a odd. So we can directly substitute in this formula. 7 is 7 minus 1 by 7, 6 by 7, 7 minus 3 by 7 minus 2, that is 4 by 5. Next 7 minus 5 by 7 minus 4. Next will be n minus 5. After that it will be n minus 7. So it is not valid up to 2 by 3. Is it right? So till where we are going to do? Where we will not get any 0 term or denominator 0 term. Till there we can do. Why did we stop here? Because n minus 5 by n minus 4, after that we directly got 2 by 3. We need not write one more 2 by 3 also. Clear? Yes or no? So up to 2 by 3. So the answer is 3 ones are 3 twos are, no more cancellations, right? 4 twos are 8, 8 twos are 16 by 7. This is the answer. That's it. But without knowing the formula we can't do it. Right? Fine. Look at the next question here. Sin square cos power 4x. Sin power mx cos power nx. So instead of m we have 2 here. What if m is even? M is even, we are going to use this formula. Let us use the formula directly. M minus 1, right? That is 2 minus 1 by m plus n, 2 plus 4 into m minus 3. There is no need of m minus 3 because itself is 2 minus 3 we can't get. So directly we have to do this integration. Integral 0 to pi by 2 cos power 4 x dx. Now we have to use this formula. 4 is even, right? Now let us substitute in this. What do we get? 1 by 6 into, here n is even, n minus 1, 3 by 4 into n minus 3, 1 by 4 minus 2 is 2 again. 4 minus 5, it's not possible. We directly got 1 by 2 and the next we have to write pi by 2. This is my answer. 3 1s are 3 2s are, therefore we will be left with pi by 4 2s are 8, 8 2s are 16, 16 2s are 32. Right? This is the simple answer. Next, sine cube cos cube dx. Sine cube, that is m is odd. So let us substitute here itself. What do we get? If I substitute 3 here, 3 minus 1 is 2 by 6. Again here it is 3 minus 3 will not have. So here directly it is 1 by n plus 1. What is n? N is 3, therefore it is 3 plus 1. 2 1s are 2 3s are, that is 1 by 3 into 1 by 4, that is 1 by 12. Right? Are these questions not easy to solve? Fine. What all we learned till now in this definite integration? We started with the basic integration, substituting upper and lower limits. Then we did this properties of definite integrals. Then we solved most of the problems there. Then we started the applications of definite integrals, where we saw few limits, few this kind of reduction formulae. And the next application we are going to learn is finding the area of a given figure. That is, for example, if I have a parabola, let us say there is some kind of parabola like this, right, and I have a straight line here. So how do we find the area between this parabola and this straight line? How do we find, right? And not only that, the general standard functions. If I say a sine function, there is a sine function, you have to know. Yes, in trigonometry we learned that is sine 0 is 0, sine 90, sine 180, like that, right? How do you find the area of this sine? Cos. Okay, these all are the things which we are going to learn in our next session. Is that clear? Fine. This is for today. Let us meet in the next session with the more problems of definite integrals. Thank you.